This video focuses on graphing absolute value functions. Please pay particular attention to these examples. These are not easy examples for us to go through. So please make sure you're pausing, you're taking notes, and you're listening. Here's our first example. We have a function. It's an absolute value function. If you remember, the parent function that we graphed in the first video had the absolute value of x. Well, this is an absolute value of x plus 1 and then plus 3. We want to find out what happens when we add 1 inside the function and when we add 3 outside the function. So we're going to be referring back in our notes to these pieces in the orange and the purple. So you want to make sure you definitely are looking at these in our notes. All right, so the number one thing you want to do is identify what is the transformations. What's happening from its original blue function to now our red function. So let's talk about this piece here. This is inside the function. So this is a horizontal shift change. We have to think opposite. We're going to push this graph to the left 1 unit. And then the second piece, now it's outside the function. It's at the end. So we're going to push this graph up 3 units. So this is going to be our vertex. So we're going to go left 1 and then up 3. And we're going to create an ordered pair. And what that ordered pair is called is the vertex. So let's go ahead and label that vertex point, -1, 3. And that's also our first point in our XY chart. Now, just like when we were graphing the parent function, we want to pick a point to the right on the x-axis, like 0, and to the left on the x-axis, just 1 unit in either direction. So I'm going to pick 0 and -2. And I'm going to evaluate the function. So remember, this is our function. So I'm going to say y equals the absolute value of x plus 1 and then plus 3. This is what we're evaluating in. So now let's go ahead and evaluate those 2 ordered pairs. So let's start with 0. Take the absolute value of, replace the x with 0, plus 1, and then 3. Now we're going to simplify that. The absolute value of 1 plus 3, absolute value of 1 is 1, plus 3, and we get 4. Now let's go ahead and do the same thing with the bottom one, -2. Evaluate the function, replace the x with -2. Absolute value of -1 is what we're left with, plus 3. Absolute value of -1 is 1, plus 3 is 4. Notice we got the same answer here and there. The reason why is they are considered symmetric. So now let's graph those ordered pairs. The first ordered pair that we found next in the blue is over 0, up 4. So over 0, up 4. And then our second ordered pair we found in the blue is left 2, up 4. Now let's go ahead and move 1 more right and left, or 2 from the center. So we're now going to pick 1 on the right, which is the value 1, and 1 more on the left, which is -3. Let's put those in our chart. And now let's evaluate the function. So we're substituting it into the red equation for x. So absolute value, replace the x with 1. And now simplify that. Absolute value of 2 is 2, plus 3 is 5. Now let's go ahead and do this for -3. Replace the x with -3. Simplify it. We get the absolute value of -2 plus 3. The absolute value of -2 is 2, and then plus 3, we get 5. Notice again, we get the same number when we go 1 right and 1 left more. So now let's graph those ordered pairs on our coordinate plane. So our first order we found in the red is over 1, up 5, and then left 1, or left 3, up 5, And now let's create our connecting points. So it goes off in the shape of a V. This next example has transformations again. Remember, our parent function is f of x equals the absolute value of x. Now let's find out what happens. So let's look inside the function first. That's a -2, and those we have to think opposite. So we're going to go opposite. You would want to think -2 means go to the left, but no, it's right 2. And then this piece here is outside the function, it's at the end, so we're going to go down 5 units. So we're going to start at the origin, we're going to go right 2, and then down 5. And what that ordered pair is our vertex over 2, down 5, and that's our first order pair, which we call our vertex. Now we're going to go ahead and pick a point on the x-axis directly to the right one and to the left one. So I'm going to go to my x-axis, right now I'm at 2, I'm going to go right 1, so now I'm at 3, and left 1, now I'm at 1. And those are the numbers I'm going to evaluate. So I have 3 and 1. Remember, what I'm evaluating is this function, the absolute value of x minus 2 minus 5. I'm going to replace every x with the numbers that I've chosen right and left. So now let's go ahead and evaluate this function for 3. So replace the x with 3 minus 2. Now we are going to simplify that. So the absolute value is 1 minus 5. 1 minus 5 is -4. Now I should, if I've done everything correctly, I should get -4 again. So 1 minus 2 minus 5. 1 minus 2 is -1 minus 5. Absolute value of -1 is 1 minus 5, and we get -4. So let's go ahead and graph those two ordered pairs. So we're graphing 3 -4 and 1 -4. So we're going to go right 3, down 4, right 1, down 4. Let's start to see our V. Now let's pick one more right and left. So we're going to go now one more right, which is 4, and one more left, and now we're at 0. Evaluate the function in the red. So replacing the x with 4. 4 minus 2 is 2. The absolute value of 2 is 2. 2 minus 5 is -3. Now we'll do the same thing again. Replace the x with 0 in the red equation. Absolute value of -2 is +2. Minus 5, and we get -3. Notice we have the same number again. So we're going to graph the ordered pair 4, -3, and 0, -3. So we go over 4, down 3, and over 0, down 3. And now we create our ordered pairs, creating that V out.